afternoon and welcome AP Physics students. This is your first installment of Labs from Your Living Room, a segment in which I show you how to do semi-accurate physics labs from your living room. Helping me out this morning is Nora Getz, who is a third grade student at Parkway Elementary and is also home due to the school closures. So Nora, say hi. Okay, so what we're going to be showing you is how to make a makeshift pendulum for your upcoming lab. So we're going to start with some not so good pendulums. A pendulum is basically consisting of something on a long string that can oscillate back and forth. So the one that Nora's going to start with is she has a shoe with one of the shoelaces partially pulled out. So Nora, why don't you show the AP Physics kids how that oscillates? Okay, so notice how that's kind of irregular. The shoe has a couple problems. One, the shoe is kind of long in length, like the actual bob of the pendulum is the shoe, and it's kind of long in length compared to the length of the string, and it's also kind of irregularly shaped with where it's attached. So that does not make a good pendulum. Okay, so, and it's also being held freehand, which of course your hand can vibrate and that can produce inaccuracies in your data. So now, Nora, can you put down the shoe and move over to the jump rope? Okay, so now we have let me just zoom in on this. We have a jump rope attached to the frame of a gazelle. And what Nora's going to do is going to release that and get that oscillating. So release that, Nora. Okay, this is a little better. Now this still has a little bit of a problem because the mass of the bob on this pendulum is basically the handle on the end of the jump rope, and the bob is not very massive compared to the mass of the string it's from, so this doesn't act like a true pendulum. Okay, so next I'm going to show you the best way to do this with stuff that I found around my home. So if you look at this one, let the kids see it, Nora. So you can see this is a head for a socket wrench, and I've tied this to a line. This piece of line is it's basically from a tent repair kit. So it's pretty thin line. So the bob is compact in like its actual sizes. So you notice how this is not particularly large in terms of its length or width, but it is heavier than the string it's from. So Nora, you don't need to do that big of an oscillation. So let's just take a step forward, or not. Okay, so you can see here that it is swinging back and forth pretty good. It'll stay springing back and forth for several oscillations stably. Also notice that this one is hanging from a lamp, a floor lamp, and so that's providing a nice stable base of support. So there's no person hanging onto it to possibly, move their hand and disrupt the data. So what you're going to be looking at around your own home is you're going to be looking for some string that's thin but fairly strong. So I've used tent string here, but you could use like wash line. You could use like a shoelace not attached to a shoe, obviously. And you're looking for a nice compact object, maybe not that high of amplitude, Nora, that you can tie it to that has more mass than the string itself. And obviously when you're taking periods of any oscillating object, it's more accurate to time multiple periods, and like say 5 or 10, and then divide by the number of oscillations that you had. So I hope this has been helpful, and enjoy doing some labs from your own living room.